Hi, I'm Rob. I'm a STEAM specialist for grades K to 8. Today I'm going to walk you through how to prepare for and run your first lesson with the LittleBits Code Kit. To get started, let's make sure our tech is set up. Download the LittleBits Code Kit app to your computer and your students' computers. Make sure you check with your IT department for lead times about downloading and installing the app onto your classroom computers. Next, plan for how to organize your workstations. Every student or group of 2 to 3 will need their own computer and code kit. Consider where you will store your supplies and set up an area for recharging batteries. Although we won't need them for this lesson, having a central location for craft and building supplies is recommended once we dive into the other lessons. Today we will be running through the Hello World lesson, which is the very first lesson in the curriculum. Even if you or your students are code pros, it's a good idea to start here, as combining visual programming with physical bits will likely be a new experience. Now, before I start preparing for my lesson, I like to try the app instructions and build the invention myself so I know what my students will be doing. It's also nice to have a working model to show them in case they get stuck. Spend a few minutes going through the instructions and upload your code to your CodeBit for the first time. When using the CodeBit dongles, the app will pick up the signal of any active code bits in the room. It's a good idea to label each bit with its unique name, whether it's in marker or with a sticker. This makes it easier for students to find and connect to their bits. Instructions for managing the code bits can be found in the implementation plan. Okay, so for lesson prep, I'm going to review the provided Hello World lesson plan and slide presentation. They are available in Google Docs, so it's easy to make changes if you want to customize or add notes. And now we're ready for the kids. The Hello World lesson provides a 50-minute introduction to the relationship between coding and electronics. After exploring how LittleBits work, students will follow the instructions in the app to create their first coded circuit. They will then be prompted to remix or change their code or circuit. Then we'll share what we've discovered. As you watch, consider how you would run the lesson in your classroom. This lesson begins with an activity where students program their teacher to do a simple task. In this case, picking up a piece of paper and throwing it in the trash. The goal of this exercise is to start thinking about how things can be broken into a sequence of actions, just like how a computer follows a precise set of instructions. So I want you to treat me like a robot. I am now Rob 2.1 gigawatt robot machine. I now specialize in throwing out garbage into trash cans. So for this activity, you're going to program me, your teacher, as if I was a robot. So take a minute and write down the steps that you would program me, how you would tell me as a robot to do that activity. Take about 30 seconds for that if you can. So, who thinks they have a good code? Hannah, why don't you start?
Move left leg up and left. Place directly down. Place directly down.
Problem.
Place directly down on the floor. Right leg up and left until you reach the chair, then place directly down.
Okay, you can do this.
Take your left arm and grab the piece of paper.
Left arm and grab piece of paper.
Left arm.
I think I got this. Left hand and grab piece of paper. Okay, what next? Walk to trash can. Place in trash can.
Then
Rob 2.0 successfully completed mission. That was a little bizarre, right? I mean, you have to be, let's just be a little honest. What was different about giving me directions as a computer as opposed to as your teacher?
As a teacher, you just say walk and you know how to walk. Then you have to do every single step over and over.
Right. It has to be really specific, doesn't it?
It took a lot more directions that it would normally say. Like you would just always say, pick up garbage, place it in the trash can, but you have to say up right leg, down right leg.
And even things like up and down were a little bit foreign to me as a robot. If up is just straight up to the ceiling, and how far up do I go to walk? And all of that would be things that we would program into a computer to make it walk, or a robot to make it walk more naturally. But naturally is sort of intuitive to us, where it's not intuitive to a robot. So we will consider that level of precision, thoughtfulness, sequence, while we're considering how to program. To explore bit basics, begin with a short video that is available in your student-facing slides. Break students up into groups and assign them to a workstation. Allow students time to explore the bits on their own to see how they work. Call on groups to share what they learned and collect responses on the board. When moving between hands-on activities and discussion, it can be helpful to establish a procedure, like unplugging the battery, so students aren't tempted to continue to play. Now we're ready to explore the code bit. Students will watch another video that introduces the code bit and walks them through building their Hello World circuit. If students need support, encourage them to first troubleshoot on their own using the debugging checklist. When they're done building, they'll insert the CodeBit dongle into the USB port of their laptop, open the LittleBits coding app, and click on Hello World. The app will lead students through the coding environment and teach them how to create and upload code to their CodeBits. Remixing allows students to take what they have built and add improvements or change the functionality. Students will receive prompts in the app to make simple changes to their code. For groups that finish early, provide additional prompts on the board. To learn more about the remix phase and how you can facilitate it, check out the Invention Cycle 101 video. When each group has had a chance to complete the Hello World activity, invite them to show off their invention and explain their thought process behind the change. When sharing, encourage students to attach their circuit to a mounting board to ensure the bits stay snapped together. Guide students through reflection questions to summarize their learnings. Efficient cleanup leaves more time for inventing and learning. Your organizational checklist can be shown at the end of each class to help students develop a consistent procedure. Encourage students to reference the diagram on the back of the bit index for returning bits to the kit trays. We accomplished a lot in just one class. Students were introduced to code and how electronics work, and then combined those two knowledge areas to build and remix their own invention. This experience will be a powerful launchpad for the rest of the activities that follow. Ready to try it in your classroom? Everything you need is on the Code Kit Resources page, including an implementation plan with tech setup tips, a curriculum guide with suggestions for pacing, whether you're looking for a 1-week course or a comprehensive 8-week unit, lesson plans, and support tools created by educators that cover Hello World and other exciting game-based inventions that you'll find in the app and beyond. If you need extra help, the LittleBits team is always available at support@littlebits.cc. I hope you have a blast building and coding with your students.